To solve this system of inequalities, we'll use a graph. Focusing on the first inequality, notice that it has the equation of a circle. That circle has a center at the origin with a radius of 3. So using that, let's start by plotting some points that are 3 units away from the origin. And notice that the original inequality there on the circle has equal to, so that means our circle is a solid circle. And from here, we need to choose a test point. The test point can be anywhere as long as it's not on the graph itself. So the easiest one is the origin. So we'll test 0, 0. And we want to test that in the original inequality. X squared plus y squared. And we're asking, is that greater than or equal to 9? 0 plus 0 is 0. And 0 is not greater than or equal to 9. We chose a point inside the circle, the origin, and it was false. That means that every point inside the circle is false. It also tells us that every point outside the circle is true. So let's make a note to shade outside the circle. Up next, we'll look at the other inequality, and notice that that is the equation of a line. We can subtract x to put it in slope-intercept form. And now we see that the y-intercept is 3, and the slope is -1. So we can get some points to help us plot this line. And notice that the strict inequality on that line is less than, so we have a dotted line. Let's make sure that line is dotted. And now, again, we need a test point to determine where to shade. Let's again test 0, 0 for the line. So going to the inequality of the line, we have x plus y. And we're asking, is that less than 3? And that one is a true statement. We chose, again, the origin, which is below the line, and it is true. So we want to shade below line. So our answer is where those two shaded regions will overlap. We want to be below the line, but outside the circle. So let's shade below the line, but make sure we stay outside of the circle. So every point in this shaded region is a solution to the system of inequalities. In this example, we will again graph the system. Up first, we have the equation of a circle centered at the origin with a radius of 2. And notice this time that circle is going to be a dotted circle because the inequality is a strict inequality. So dotted circle. Now determine where to shade. We'll choose a test point. We can test any point we want as long as it's not on the circle. Let's test 0, 0. Go back to the original inequality. We have 0 squared plus 0 squared is less than 4. And we're asking, is that true? 0 is less than 4 is a true statement. So since we chose the origin and it was true, we want to shade inside the circle. Next, we will look at the other inequality. Notice it has the equation of a parabola that has been shifted down 1 unit. So let's look at that parabola and plot those points. And this one is a solid parabola. Notice the original inequality has equal to in it, so this is a solid parabola. Let's use a test point. Again, we can test 0, 0. Plug that into the original inequality, and we get 0 is greater than or equal to -1. That is a true statement. So we want to shade inside the parabola. Keep in mind our answer is where the two shaded regions overlap. We want to be both inside the circle and inside the parabola. So we'll shade that region that is inside both shapes. And every point in that shaded region is a solution to the original system.